Hey everybody, so we're building onto ionic bonding a little bit. So last time we were just dealing with compounds that just had two types of elements. So we were dealing with things like NaCl, we were dealing with AlN, we were dealing with AlCl3 or MgCl or F2, right? We were just dealing with compounds that had two elements, either Na and Cl, aluminum chlorine, aluminum nitrogen, magnesium fluorine, okay, things of that nature. But now what we're dealing with is we're going to deal with polyatomic ions, which deals with more than two types of elements, okay? And those are things such as like NaNO3, NH4OH, AlSO43, Al2SO43. Okay, you're going to be dealing with elements that have polyatomic ions in them. So let's talk about polyatomic ions. Now what I want you to do is I have posted this polyatomic ion sheet onto our topic for today. You can use this on any test, quiz, worksheet, anything. All right, this is for you to look at and to help you on the test. I don't expect you to memorize all these. If you decide to take AP Chem, you will have to memorize all these. But what they are is they're just a list of polyatomic ions with their name, as well as the charges on them. So all these guys have a -1 charge. These guys have -2, -3. And there's only one +1 polyatomic ion, and it's that ammonium right there. All right, so get used to when you're starting doing worksheets, you pull out your periodic table, and you're going to pull out this guy. He's going to be your best friend. So polyatomic ions, what are they? They're pretty much just ions. Remember, ions are atoms with a charge. Ions that have multiple atoms but act like a whole atom. So pretty much I just like to call these hybrid elements. They're pretty much just a bunch of elements compounded together, but they never break apart. They always stay together. They're just super elements is what I say. So examples of these are like OH-, which is our hydroxide. We got NO3-, which is nitrate. We got PO3 negative, which is our phosphate, or phosphite, sorry. And then we got SO4 which is our sulfate, and so on and so forth. You'll see these polyatomic ions. They're hybrids. They got these multiple elements going on. Okay? The charge is always in the upper right. So what we got to do is we got to be able to combine these polyatomic ions with other metals and be able to name the compounds, kind of similar to what we were doing the other day. So let's go ahead and let's do a couple examples. So what I'm going to do is I'm going to say we got calcium and hydroxide, and we're going to combine these guys. We're going to try to do our best to combine them and make sure that they are neutral, just like our regular ions or atoms that we did the other day. So let's first of all list the charges on these guys. Ca is calcium, it's just an element. We go to the periodic table and we see that it is in the +2 column. So it's got a +2 or a 2+ charge. I go over OH, I see that that's a combination of two different elements, oxygen and hydrogen. I'm going to look on here for hydroxide. Hydroxide is OH-, it's right there, and it's got a -1 charge. Alrighty? So we're going to combine both of these guys. Again, we cannot have a +1 charge on a compound. It's got to be neutral. So really what we're going to need in order to make this neutral is we're going to need a second hydroxide. So then when we go and combine these, you are going to go Ca. I'm going to need 2 OHs. Now this is what you can't do. You can't go OH2 because that is not two hydroxides, okay? That is 1 calcium, 1 oxygen, and 2 hydrogens. Remember, we need 2 hydroxides. So what you do is whenever you're going to have more than 1 polyatomic ion, you put it in parentheses, okay? And then you'll put how many you need on the outside of those parentheses. So what we're saying is I have 1 calcium and 2 hydroxides. Okay, I got just what I put over here. But remember, you got to put it in parentheses. If you don't put it in parentheses, that's saying I got 1 oxygen and 2 hydrogens. That's not right. We need to have 2 hydroxides. Okay, let's do another one. Oh, let's name this first of all. Okay, luckily these are just easy. You just name the first element, right, which is calcium. And then for polyatomic ions, you just name those too. Okay, so on our polyatomic ion sheet, the name of it is hydroxide. So we're just going to put hydroxide. Okay, calcium hydroxide. That's all it is. You just, sorry, I'm out of room there. There you go. So list the first element, and if it's a polyatomic ion, you just name it. Okay, you don't have to keep the prefix and put "ide" at the end. You just say calcium hydroxide. This is a strong base. Okay, can eat your skin, all right, but can be used in some cleaning materials if it's diluted enough. Na and NO3. Na and NO3. I look at this, I say, okay, what are the charges? Sodium, first column, it's got a +1 charge. I see an element here, it's got 2 different elements in it. I'm thinking this is going to be a polyatomic ion. I go ahead and I look at my polyatomic ion sheet. I'm looking for NO3. It is nitrate. It has a -1 charge. Lucky for me, +1, -1, I don't have to add any more sodiums or any more nitrates. So this just becomes NaNO3. In this situation, I don't have to put a parenthesis around that nitrate because there's only one of them, right? If I put a parenthesis around that, that's just kind of redundant. Don't do that, okay? If there's only 1 polyatomic ion, you don't need parentheses, okay? That's why up here, when there was more than 1 polyatomic ion, I went ahead and I put 2 there, okay? But if there's just 1, leave it. And then naming isn't so bad, right? It's just name the first element, sodium. Name the second element, or since it's polyatomic ion, you just name it, which is nitrate. All right. So now, what we're going to do is some examples where we're mixing in like regular ionic bonds on the periodic table and polyatomic ions. So let's go ahead and let's get a nice mix of that going. Okay, so here I have a bunch of compounds that I want you to name. This is where you have to realize, okay, now I can have mixtures of just regular ionic bonds with a metal and a nonmetal, and I can have a mixture of metals with polyatomic ions. So we got to be able to identify those. I'm looking at this first one. I know that's an ionic bond because it's got a metal and a nonmetal. It's got something on the left side of the stair step and something on the right side of the stair step. Is there a polyatomic ion in this? No. It's just 2 elements, right? Magnesium and bromine. So I will just name this like I did last time, right? I state the first element, which is magnesium. And then Br is bromine, but I'm not going to say bromine, right? I'm going to say bromide. Bromide. Magnesium bromide. Okay, keep the prefix and add "ide" at the end if we have just 2 elements. The next one, I look at this guy, and you're starting to see that there's more than 2 elements here, right? There's calcium, nitrogen, and oxygen. So this has got to be a polyatomic ion. All right? This looks like the polyatomic ion because it's in parentheses. So what we do is we just state that first element, which is calcium. And we state that second polyatomic ion, we just name it, which on our periodic table, NO3, right? We're just looking for the thing that's in the parentheses. Some of you will be looking for NO3 in parentheses 2. no, it's not on there, right? We're just going to be looking for NO3, the thing that's in parentheses. Which, if you look on there, it's just nitrate once again. And we just say it, so it's calcium nitrate. Okay. This one, we're looking at this one down here. It looks like, okay, we got another polyatomic ion going on here. You might look at this and be like, whoa, what's up with this? It looks like the polyatomic ion is in front. Well, the only polyatomic ion that could be in front is that bottom one down there that's got that positive charge, right? We always put the positive ion first, and it's going to be ammonium. Okay, ammonium. And then that second element, right, by itself is oxygen, but we don't say ammonium oxygen, we say ammonium oxide. Right, ammonium oxide. If an element by itself is second, you always change the suffix to ide. That last one, aluminum and iodine, it's only got two elements, right? Aluminum and iodine, so we just name this as normal. Aluminum, or aluminium, if you're from across the pond, and iodine, it's not iodine anymore, it's iodide. Iodide, okay? So those are some examples where you're going from the chemical formula to the name. All right, now here we have a situation where we're going from name to formula, and I've thrown in some polyatomic ions ones and ones from our some regular ones in there from last time as well. So I'm going to look at these, and I'm going to start with this first one up here, sodium sulfate. Sodium, I know. Sodium is just Na, and I'm going to state the charge, which is plus. Okay, sodium sulfate, Na plus. Sulfate, okay? Anytime you see something that ends in ate or ite, it's on the periodic, or it's not on the periodic table. It's on the polyatomic ion sheet. Okay, anytime you see something end in ate and ite, it's on here. So, sulfate, sulfite. Usually everything else that ends in ide is on the periodic table, or except for hydroxide, which is OH minus, and cyanide, which is CN minus. Those are the only two that end in ide that are on the polyatomic ion sheet. So, we're looking at this one, sodium sulfate. Sulfate, it ends in H, it's on the polyatomic ion sheet, and it is SO4 2 minus. Remember, once again, I gotta make this neutral. So right now I have 2 minus charge and a plus 1 charge. I better add one more sodium to that. Now it's going to be neutral. Okay, so now my compound is going to be Na2SO4. No need to put the singular elements like sodium in parentheses. Right? I'll bring back magnesium hydroxide in a second. Potassium bromide. Okay, potassium. Okay, just plus. Bromide, remember it ends in ide, so it's on the periodic table. The only ones that are the exception to that are hydroxide and cyanide. So bromide came from bromine, which is Br minus. Plus charge, minus charge, these are already neutralized, so this could just be KBr. So there, let's bring back magnesium hydroxide. All right. Magnesium, Mg2 plus, hydroxide. Some of you will see that hydroxide and you'll be thinking hydrogen. And you'll be thinking, oh, cool, I put an H plus here. Well, now you see 2 positive charges, you know something's wrong. You're saying, oh, wait, hydroxide must be something else, okay? You're right. Hydroxide is going to be our polyatomic ion, OH minus, right? Hydroxide OH minus. So, OH minus, but once again, I need to make this neutral. So I have 2 plus charge, I have a minus 1 charge. You better get one more hydroxide in there. So in this case, right? We got one Mg. We got two OHs, but remember, since it's a polyatomic ion, I can't just do that. That's a big no-no. I gotta put it in parentheses first, and then put a 2, so that it encompasses the whole thing, and it says I got 2 hydroxides. Alright, last one, aluminum phosphite. Aluminum, that's an easy one. Al plus 3. Phosphite, it ends in ite, I-T-E. So I'm thinking it's going to be on my polyatomic ion sheet. Phosphite is PO3, 3 minus. Hey, this is really nice. It's Al plus 3, PO3 minus, or PO3, 3 minus. So these guys just cancel out one another. So it's just going to be Al, PO3. No need for parentheses because it's just one polyatomic ion. Okay, so that is polyatomic ions, guys. I'm throwing in a mix, so make sure that you're looking on it, getting used to looking at that polyatomic ion sheet, noticing when I have to use that or when I just do normal naming, like a metal and a non-metal. That's it. Have yourselves a good day, guys.